You are listening to the Wi-Fi Ninjas podcast, where we talk about wireless technology. Here are your hosts, Mac Daring and Matt Starling.
Hey everyone, welcome to the Wi-Fi Ninjas podcast. Matt and Mac here, but we are also joined with a very good friend of the show, Mr. Jim Palmer. Thank you very much for joining us today, Jim. How are you?
I'm doing well, Matt. Thanks for having me.
Oh, it's an absolute pleasure to have you back on the show for the second time, and this time in slightly different circumstances. So not in the previous role that you were in before, and hopefully coming out the back end of a global pandemic.
Yeah, I think when I joined you last time, I was still at the airport in Denver, and now I can actually say it. I can say the airport that I was at.
Yeah.
Since then I've actually transitioned and I've moved over to CommScope Ruckus. So that's the official name, if anybody's wondering, is CommScope Ruckus. And so I'm working on the vendor side and doing some pretty interesting things. And so I'm really kind of enjoying it. Unfortunately, 2 months after I made the move, the global pandemic happened. And so I'm not really sure I've ever seen my real job yet.
Mm-hmm. Well, I mean, there's a great podcast that we done last time. I still reference it in a lot of the Echout ECSE classes, and I actually send it to some of the customers when they talk to me about wanting to rate limit Wi-Fi. I just be like, hey, just go listen to this podcast or go read this blog that Jim done. We don't even need to have that conversation. I pass all that work off onto you. So thanks for that, Jim.
Anytime.
Funny, man, I'm doing exactly the same thing in my classes. Like every time I mention our podcast that we've done together almost 2 years ago, or it was even more than 2 years ago now.
My time is all messed up. I have no idea. Like, I'm just like, this past year has wrecked me. I have no idea what's going on.
Yeah,
well, you're not alone.
Yeah, it's flown by. But a very juicy topic that we are going to be covering on the show today. So do you want to just maybe talk about what it is we're going to be talking about?
Yeah, so we're going to talk about Mac randomization.
And
which is
not Mac as in Mac here, actually, Mac addresses.
He seems pretty stable. I mean, he looks about the same as I've seen before. So yeah, our Mac is stable. We're talking about the layer 2 Macs.
Yeah, I wouldn't call myself stable mentally, but yeah.
Oh, good point.
On the camera with the hat on, it's not too bad, quite stable.
You look good though.
Thank you very much. Likewise. Shall we grab a coffee together next time we see each other?
I think we should.
Good stuff. Okay, Jim. So thank you very much for coming onto our show to discuss this very relevant topic now. Why I think it's relevant is like it starts to break our flows in our professional world. Like me and Matt, we are working in the integration world with different vendors now, mostly Cisco, and we can see the impact of Mac randomization in the real world, that it is breaking our flow, it is breaking our splash pages, it is breaking multiple different things at the expense of fixing the privacy of our users. So let's maybe start with the Mac randomization, what it is, and maybe before we go there, why am I asking you this question? I was looking for the answers to these questions myself last week, and then I found your blogs. It's like a series of 3 blogs, I believe, posted on CommScope Ruckus blog platform. And they are amazing, easy to read, not too long. So I think you spread them over like 3 shorter blogs, not your style, this kind of stuff. But they were easy to digest, okay, in these 3 different parts. So it's not a bad thing. And you've answered quite a lot of questions about Mac randomization there. And so far, I believe that this is the best source of the information on the web about the Mac randomization out there after spending a few hours reading about the topic. So thank you very much for contributing your experience about Mac randomization with the community. And maybe let's kick off with what the hell is Mac randomization?
Well, thank you for your kind words. And, there are 3 blog posts, and I kind of talked about it. I did a personal blog post because I realized that our corporate one didn't do a really good job of linking the 3 blogs together. And yeah, it wasn't my call to do a very short one. That's sort of that's the corporate world saying that, look, you can't write your 5,000 word blogs. You got to break it down. So that was interesting. But this all started last summer, so August of 2020. And, I got a ping on a Friday evening as I was getting ready to enjoy my weekend that said, "Hey, guess what's happening?" And I was like, "Oh, no." And so we got to go backwards a little bit, and we talk about the impact and why it's an impact. And I explained it like this. When you look at the OSI model of the networking, and you have the 7 layers, and we usually live in layer 1, layer 2, and sometimes we peek up into layer 3. But for the most part, layer 1s and layer 3s, they change a lot, whether you're going from wired to wireless, or you're changing channels, or you're changing bands. That layer 1 changes all the time. And with DHCP and dynamic IP addresses, layer 3 changes a lot. And the one thing that we've really counted on is this layer 2. Layer 2 is stable. Layer 2 is where Wi-Fi lives. And because of that, we have a lot of networks and a lot of systems that rely on layer 2 being super stable in order to run networks. And it also gives us a lot of insight into the devices and then the users that are carrying those devices on our networks. We're able to say, yes, we saw you in our in our store 3 weeks ago, and now we're seeing you today. And we know that both times you went down, you were in this area because you were connecting to these APs. And so we know that you're probably coming to our store for produce. And so we start to build a bigger picture. Well, in today's world, privacy is becoming a commodity, really. I mean, it's a really big thing. And so what client developers, the Apples, the Googles, the Windows, the people that do the client side stuff started to say, this is becoming a concern. So they took a feature that's been in Wi-Fi for a while, which is when a device was probing for, doing like a wildcard probe, it would use this. It's a randomized MAC. The 802.11 standard, or 802 standard, really, because it's used in wired and wireless, defines this as a locally administered MAC address. The developers call it a private MAC address, but what's happening is it's just randomizing the MAC address. It's like, hitting spin on a dial, and it's like whatever characters show up, that's what we're going to use. And so they've been using these for a while to probe. And what they said is, wow, if we can sort of hide people's privacy and kind of pull that back towards the end user, we can do this not only when the devices probe, but also when they connect. And that's when we got involved. That's when, my company, other companies, other vendors, everybody gets involved and goes, wait a second. We've counted on this layer 2 being super stable to help us build our networks and run our networks. And yeah, we get to track people, but now you're gonna spin the wheel on us, and we're going to make it, you're gonna randomize it. And we all just kind of, not only the wheel spinning for the MAC addresses changing and coming up with random digits, our heads started to spin, and we were like, wow, what is going to break? What is going to happen? And so that's when I got involved. That's when I wrote the first 2 blogs, was to try to help people understand, okay, what do we know? What do we think is coming, and what's going on? And so that's kind of what's happening is more and more and more so iOS 14 introduced devices connecting using a randomized MAC. But honestly, this has been a thing since Android 9 a couple of years ago. Android 9 and Android 10 started this. Windows 10 has had this as an option for a couple of years as well. But people sit up and pay attention when Apple does it, because when you look at the adoption rate of iOS, when the new iOS versions drop, even iOS 14, it dropped in September of 2020, and by December of 2020, 83% of all eligible devices had upgraded to iOS 14. When you look at Android, 10, and I think we're Android 9, Android 10, I think we're up to Android 11. I don't know, I don't track them, but they're only at 16%. And so when Apple does something, the impact is far reach. It's a bigger impact, because everybody upgrades, just so that little blinking thing on your screen that says you need to update, and you go, fine, I'm going to update just so you stop bothering me, not because you think you need it. And so that's where we start seeing it. So that's when this all came about, is when iOS 14 dropped in September of 2020. everybody updates to it, and then we start seeing this impact.
Yeah. So Jim, are you saying that Android 9 and 10 they had Mac randomization turned on by default, and we just didn't use it?
And this is why I like you. You picked up on that. It wasn't turned on by default. Android 10 was. Android 9 was an optional feature. And even today, Windows 10 is still an optional feature. iOS skipped that whole, we're going to enable it, but make it an optional feature that you can turn on. And they said, we're going to jump straight to enabled by default. So even though Android 10 was enabled by default for new networks, iOS 14 said, we're just going to enable it for everybody across the board. And in a very weird thing that caused me just a ton of heartache was the fact that when iOS 14 first dropped, and you'd go look at your screens, look at your configuration on your iPhone, it would say that your phone was using a private MAC address. And that's a term from the developers. So like a marketing term. But it would say, hey, I'm using a private MAC address. However, it would still show that you were using your burned-in MAC for the first 24 hours, which was something we didn't expect to see. And so when it happened, we all went, well, that's new. But then 24 hours after, upgraded to iOS 14, it then switched the MAC address. It went from your burned-in one, and it started using a private randomized MAC address. Yep.
Yeah, for everyone that's just listening only, Mac was holding his phone up to the camera. Not really useful for everyone if you don't say what you're doing, Mac, for the people that are listening to audio only.
Yeah, so on the different devices, you can go in and you go look at the information about your connection, and there'll be a little toggle that says, hey, use private MAC addresses, and it'll tell you the MAC addresses it's using. Now, to identify it, I'm going to get really, really, really nerdy here for a second. So hopefully the listeners will bear with me for a second. A randomized or a locally administered MAC address is what the standard calls it, is identified by the second least significant bit in the most significant octet of the MAC address, which is a lot of words that if you want to impress somebody at a party and get them to leave you alone, just use that little tidbit. Just be like, hey, you know what? A locally administered MAC address is identified by the second least significant bit in the most significant octet being set as a 1 and not a 0. And no one will ever talk to you again at a party. But
except for nerdy birds.
It's very nerdy. So what that means is when you look at the 1s and 0s of the MAC address, and you can see this in Wireshark. I break it down in some of my presentations where it will actually show you, and it'll be like, oh yeah, this bit is a 1 and not a 0. That means it's a locally administered MAC address. Now that gets to the next point of what Mac was showing on the screen that people listening won't see, is what that does is it creates a special character, not a special character, but a unique character in the second position of the MAC address. So the MAC address is 2, 4, 6, 8, 10, is 12 characters. They're separated into 2 hexadecimals characters. So you'll get like a 2E colon or dash, however you can display it different ways. But they have the 2E, and then you have those sets of characters. The first 3 sets is known as the organizationally unique identifier, or OUI. And up until this point, that's how we'd figure out if you were an Apple device, because Apple has registered OUIs. And so it goes, oh, the first 6 characters are this, that's an Apple, it's an Intel, it's a Samsung, whoever. And that was one way we could identify it. But what happens is when that bit is set, that second character can only be one of 4 characters, which is a 2, a 6, an A, or an E. And I've told people since August when I first memorized this, if there's one thing to learn, it's those 4 characters: 2, 6, A, and E. So when you see those as like a 2A or 7E, when you see that second character as one of those 4, you know it's a locally administered MAC address that's been randomized, and you may or may not be able to trust it being the same tomorrow or next week. And we'll get to that here in a second.
Okay, so this is meant extremely interesting to know. I think that last year or 2 years ago, actually, when I started seeing broken flows in the splash pages that do rely on the MAC address of the device, It might have been the Android devices with the Mac randomization turned on, at which point we didn't know about this feature being turned on by default, or we didn't pay attention to the new settings in the wireless LANs, SSIDs settings that probably you could enable or disable a private MAC address, right? Or was it just enabled by default and you couldn't do anything about it?
Well, and that's what made it interesting is when you looked at Android 9 wasn't enabled by default. It was an optional setting, but it wasn't like it was I got to jailbreak my phone and I got to load the developer software or whatever. It was just a setting in your, and so if you went and played with it and you went, hey, look, here's this cool setting, I wonder what that does, and you hit it, then it started using it. And so when Android 10 came out and they said, oh yeah, we're going to enable it by default, and then iOS 14 did the same thing, but because you didn't see as many devices on iOS or on Android, it wasn't, you just sort of chalked it up as a one-off. But it could very well be, that was, it was something that we were seeing, but you didn't really know it, but you just kind of figured out, because more importantly, what was happening was it would use a random MAC address, 2A, but it would use that same random MAC address for the rest of the time. It didn't change. And so this is kind of where my most recent blog post came from, was this idea that, yes, we are now using random MAC addresses. It's a 2A. So you can't identify somebody. But when you look at my third blog post, I looked at my controller here at my house, and within a week, I had fingerprinted my device pretty clearly. I mean, I knew what iOS version I was running. I knew everything about it, because my MAC address, even though it was a random MAC address, it was the same MAC address that I've been using for weeks, months, even years. And so at that point, is it really private anymore? What privacy have we gained? Because you and I and everybody listening knows what a MAC address is, but all we care about is it the same MAC address day in, day out, week to week, especially when we start troubleshooting. Hey, this is the same MAC address has problems on Monday mornings.
Okay, so how often do you think the MAC address changes on different operating systems? So on Android or on iOS or Windows, whatever, when you enable it, how often does it change?
So can't believe I'm about to say this, but that's a really good question. iOS today doesn't change. When I got involved was iOS 14 beta test number 3, because in beta test number 3, it was changing every 24 hours. However, when it actually went to the general availability, GA, they dropped that feature. They said, oh, you know what, we're going to back off of this, and we're not going to change it every 24 hours. So when Mac held up his iPhone to the screen and was showing us whatever MAC address he was using for that particular SSID, that's the same MAC address that Mac has been using. Oh, we can't use you as an example anymore. This is getting confusing. So we're gonna pretend that Matt held it up. So when Matt held up his phone and it was showing this one MAC address for that one SSID, it's been the same one ever since iOS 14. He upgraded to iOS 14 in September. Android, in the latest releases of Android, there's a developer option that you can go into. You can enable the 24-hour feature. So it's there. You just have to know to go look for it. You got to click on a lot of screens. What's interesting is Windows 10. If you have a Windows 10 laptop, and I have one behind me on my test bench just for this reason, if you go look at the WLAN setting and you go, oh, I'm connected to my home network, and then you scroll down just a little bit. I mean, it's not like scroll. It's you just click, you go down a couple of lines. There is the ability to enable 24-hour changing, just as it's an advanced option, but it's not hidden. So my fear is you're going to have some IT help desk guy who's running around with his Windows laptop, and he's bored one day and says, oh, I wonder what this does. Let me enable this. But because it's not hidden. Now, based on sort of, as you look at the history and you kind of figure out how this came about, I think it's just a matter of time before iOS goes to 24-hour features as a default, because they don't like to do the enable and let you turn it on. They're just like, we're going straight in. We're going to jump both feet into the deep end of the pool. So my theory, and this is just me personal theory, I don't have any other additional insight. I believe that when iOS 15 comes out, that 24-hour feature is going to be enabled by default. And I think that very quickly after that, you're going to see Android and iOS, or Android and Windows, turn it on by default as well.
So what's the actual impact that's going to have to us as end users and you as vendors, or to our Wi-Fi networks?
So we'll start with the end users, because this is where it's sort of being marketed to, or being set up for, was, hey, end users, we're going to be able to protect your privacy. So end users are going to start seeing, from a functional standpoint, once they're connected, not much is going to change. You really can't just change your MAC address in the middle of a session. It sort of breaks the whole, switching concept of send it to this MAC address that we see over here. So you can't change it there. So from a connection standpoint, once you're connected, you're not going to see anything. However, trying to get connected is going to change. And a lot of that depends on how the network that you're connecting to is configured. So if you're using a pre-shared key, like a personal pre-shared key or an individual pre-shared key, or there's every vendor has their own unique way of saying, hey, this one device is going to get to use his own, password to join, and everybody can have their own unique one. Right now, that there's a slight glitch, because you go, oh, I changed from a C0 to a 2A, so I had to reassociate my individual pre-shared key to the new MAC address. So you had that hurdle, you got over it, everything's done. It's like a Y2K thing. We thought the world's going to burn down, and then it really didn't. And so what's going to happen is everybody's kind of going, oh, random MACs are now over. Well, it's not. When they start changing 24 hours, and you have this direct relationship between a MAC that never changes, even though it's random right now, and a password. So when that one MAC address says, here's my password, and the system goes, oh, that's not for you because you're not 2A, you're now 7E. And you go, well, yeah, I changed. Well, yeah, that's no good for me. So what's going to happen is anybody that's using a single mapping pre-shared key for a unique device to a unique password, that is going to break at hour 25. And it's going to be just a massive pain in the butt. Anything that has to do, like Mac was saying, captive portals. Captive portals like to use that MAC address and say, oh yeah, you logged in 2 days ago, and my setting is to keep you, you get 5 days of access, and then we kick you out. So, going to a hotel. Hotels are a great example of this. They love to use their splash pages. Some hotels are like, you have to log in every day, or you only have to log in once at the beginning of your stay. Now, if the portal says log in every day, or like I was at a hotel and it was log in every 4 hours, I mean, they must have hated us. I mean,
that must have been fun.
Well, it was like, oh, your device goes to sleep. Oh, kick you out. 4 hours, kick you out. It's like, man, every time we turned around, it's like, got to log in through the portal again. That type of thing, there's actually no impact. You can still hate your customers and make them log in through the portal every 4 hours, because that MAC address isn't going to change that quick. But for the hotels, they're like, hey, we kind of like our users, and we're going to let you log in once at the beginning of your stay. Well, at hour 25, when the device changes its MAC address, the portal goes, oh, that's a new MAC. I'm going to make you sign in again. So it really depends on how you run that type of network. And so for hotel operators, and I tell people this all the time, I think I even wrote it in one of my papers or blogs or whatever I've done. It's like, if you're running a portal and you're trying to do it on the cheap and kind of, hey, I'm going to use some janky thing, it's just not going to cut it anymore. You have to have a more advanced portal solution that can handle this type of thing, that can do more than MAC address. When was the last time I saw you log in? It's got to do more than that, or else you're going to go back to, I hate my customers, and I'm going to make them log in every 4 hours type of thing.
Yeah, captive portals cause us end users, as network implementers headaches, because I don't know about you, but I have lots of customers that try and implement a captive portal, and then you install it, it works okay, then you get a call a few weeks later saying, actually now the captive portal just isn't loading on some of these devices that were working a few weeks ago. So it's just, this Mac randomization is just kind of adding like another reason to give us a headache with a captive portal, because sometimes, the client doesn't get the HTTPS redirect, or it's just HTTP only, it doesn't like it, or it just doesn't get prompted. And, to the end user, they just turn up, they just want to connect to hotel guest SSID and then just be connected. They don't care or know if they should be getting a captive portal or not. If it just doesn't load, then what are they supposed to do?
Well, Wi-Fi is broken.
Yeah, exactly. But if you've gone through the process of physically connecting, getting yourself an IP address, and then all of a sudden you've got a captive portal, you've gone well past layer 1 and layer 2.
Exactly, but the problem is, at the end of the day, we still get the call.
Yeah,
Wi-Fi,
yeah, of course.
Wi-Fi is broken.
Mm-hmm.
So, I've said this. I've done captive portals because that was the requirement. That's what they said. We need to have a captive portal. The lawyers are saying we have to have a captive portal. And quite frankly, if a lawyer comes to me and says, I'm mandating that you put in a captive portal, I'm not going to argue that, because I'm not a lawyer. I'll argue that the technical side of it, but when the legal guys start saying legally we say you have to have it, fine, I'll do it. But I also know that I'm a really crappy programmer, and I'm not good at doing, building these pages and doing this kind of thing. So in the past, when I would do sort of this half-baked solution to say, fine, you want a portal, I'll build you a portal, and it'll work. It'll do that checkbox on the legal requirement, but I can do it for cheap, and I can do it cheap for my customers. Unfortunately, that's just not going to cut it anymore. You're going to have to find somebody that does, that builds web pages, that builds this kind of thing, that is good at doing extra features and extra, functionalities on these web pages, and not just, I'm gonna send you the web page, and maybe we figured out how to get around the HTTPS redirect, and we can handle all that. But now there's this other, hurdle that's been introduced, and I tell people all the time, it's not like as a vendor, I went to Apple and Google and Windows and said, hey, can you please turn this on because I want to sell my customer more gear. That we didn't want it. I mean, we're still fighting our own battles with it. So it's just the unfortunate truth is we're going to need a more robust portal solution in order to handle this development in the future. We can't just go, we can throw it up on a quick, cheap, down and dirty one. We're just gonna have to use a better solution than one that's designed to do this.
So that is not available yet on the market, right? We don't have a solution with a splash page that is not reliant on MAC address yet. And if we wanted to leverage something that we have available today, as you said before, Jim, you will need to use a private MAC address, not private MAC address, personal PSK or identity PSK, whatever it's called, and not put limit of the amount of devices that you can connect to the network with this particular PSK, right? Because if you have like one-to-one MAC to PSK association, then it will break. So if you expect your guest or your corporate user to use personal PSK over multiple days with a device that changes MAC address, then every day, every time it changes, it will be logged in as another device. And if you have like a limit of 3 or 5 devices, at some point it will break as well.
So I want to back up a little bit, and let's talk about enterprise stuff. Let's get back to things that won't break. If you're using WPA2 or WPA3 enterprise, and you're doing that enterprise-based authentication that uses radius and stuff like that, it doesn't rely on the MAC address. Now, I know some vendors will do what's called a MAC Authentication Bypass as part of the .1x. That's broken, obviously, because you can't count on the MAC address never changing. But if you're doing a different type, if you're using a different EAP type, then that doesn't rely on the MAC address. You can use, if you're using AD credentials, it doesn't care what MAC address those credentials are coming from. If you're using a cert, if you have a certificate, on your client device and on your corporate network, and you're using EAP TLS, that doesn't break either, because it doesn't care about the MAC address. It only cares about the certificate. So there are certain things that, while it sounds scary, it doesn't break. Another one that has come up a lot is IoT. Now, at this point, we don't think that IoT is going to go there. We don't think that IoT devices are going to enable it, random MAC addresses, because what privacy are you, protecting from the network operators from an IoT device? Because the network operators are usually the ones who deploy the device. So, so I don't think we have to worry about an IoT type of thing, because if I'm the network operator and I'm like, oh, we're going to do IoT, we're going to do temperature sensors or whatever sensors or whatever we want, we're going to put that on there. I'm the one that's putting it in place, so I'm going to be like, yeah, I know everything about that device. So there's no privacy anymore to protect because it's my device.
And let's face it, right? How many IoT device sensor builders care much about security?
So IoT security is, again, that's weeks worth of podcasts, and we're not going to go there. Let's just I mean, this was a call I was on, literally yesterday, when it was like, well, what about IoT? And it was like, well, okay, let's IoT security is one thing, and we're not going to, that's different thing. But yeah, IoT has its own things. And how many of the listeners have barcode scanners that are still running like, Windows ME or Palm, or, I mean, I see it all the time on all the chats and everything, where they're like, oh yeah, I have an 11G barcode scanner that's running Palm OS. And you're like, okay, yeah, that's a whole other issue, but random MAC addresses on that device isn't a concern.
So robust and so stable. Why do you need to change it, eh?
It still works, We've dropped it 8,000 times from, 3 shelves up in the warehouse, and it still works. So yeah, we're going to keep it. So crap, now I forgot where we were going with that. What was the question?
Well, just a quick recap of what is and what isn't working then. So what's going to potentially cause us some problems is captive portals, personal pre-shared keys or identity pre-shared key. Depending on what vendor you're using, they'll have a different term or phrase for that. So that's where you can have multiple pre-shared keys tied to unique devices, but not actually the type of the pre-shared key that's most common that we're talking about. So WPA2, just or 3 pre-shared key, that won't be affected with the random MAC.
Yeah, because you have 800 people using the same pre-shared key that hasn't changed in 8 years.
Sure. And then so enterprise as well. So WPA2 enterprise, WPA3 enterprise should still be okay with the random MAC. So out of the 4 different authentications, 2 is potentially going to have some more headaches because of the MAC randomization.
Right. So I'm going to turn into a little bit of a marketing guy here for a second. And because Mac said that, there's not a portal today or a portal solution today that can handle this. There is actually. And when you start talking about that individual, pre-shared key, there actually is a solution today for that. And it's been on the market. It requires a little different change in thinking. And it's actually a Ruckus innovation that Ruckus pioneered. And so the Ruckus version of that is called a dynamic pre-shared key, or a DPSK. And in the traditional sense of the Ruckus dynamic pre-shared key, it was a one-to-one mapping. But there's a couple different flavors of the Ruckus DPSK. There's what's called a bound, which is, I originally set up, I go in and I say, this MAC address is going to use this password. And so we know that's broken. Then there's an unbound DPSK, which is, if you're coming to visit my facility, I'll build you a password before you get there. You walk in the door, I hand it to you, and I say, here's the password to get your one device onto the network. And then the first MAC address that uses that password, it then gets bound to it. So then it creates that one-to-one mapping, automatically with the first user who uses it. Problem is once it goes to a bound, it's now broken. But the third flavor of the Ruckus, CommScope Ruckus dynamic pre-shared key, is what's called a group DPSK. This group DPSK works almost exactly like the other personal pre-shared keys, except it allows you to use multiple MAC addresses on the same key. So at that point, I would build a group DPSK for Mac, and I'd build a different group DPSK for MAT. And when you guys showed up at my facility, it'd be like, you're going to be here all week. Here's your key. and you can use as many devices, or I can limit you to 3 devices or 5 devices, and be like, that way you can use your phone, your tablet, your laptop, and then a fourth device. I'll be like, Mac, you get 4 Mac addresses that can connect. Matt, you get 4. But if you think about it and you go, well, instead of treating, the group Dpsk as I want to, I'm going to use it for just a bunch of different devices. What if it's one device that changes its password once a day?
So if you use a virtual MAC address, then you have no limit for that type of MAC, or how do you do that?
So you can still set the limit, but, and I think this is one of the reasons why Apple pulled back on the 24-hour feature and didn't enable it by default, is because we're still working on the coding on the backside that says you used a random MAC address, and we saw it 3 days ago and we haven't seen it since. So we should probably flush that out of the table, because we're pretty certain we're not going to see it again, because we've seen these other, and so it's a relationship between, is it a random MAC address, and when was the last time we saw it? And so when it becomes stale, and again, this is stuff that from our perspective, we're still working on the backside of building that coding in, so that we can just basically do a code upgrade when it comes out and say, hey, if you're running on this version of code, it will flush these stale MAC addresses out of the backside. And that way, that solution exists today. That solution existed, a couple of years ago. And so that does exist today. Now, other vendors, I can't speak for them, but other vendors, are having to do some different things. But from a Ruckus perspective, that's a feature we've had for years.
And that's nice. I think you can also use like third-party tools like WiFlex or whatever, something like this, that can work using APIs with any vendor that supports it, to create the multiple or identity or Dpsk for the users with like a sleek tablet and the barcode scanning stuff with your phone camera and things like this. And it might work for every vendor that is not relying on MAB, right? On a MAG address to use with the multiple or identity or Dpsk. So yeah, that's good that we have like a choice. So if you have a Ruckus, what is it built into? In a Ruckus NAC solution?
So it's not so the group Dpsk is actually, it's native on all of our platforms today. Okay. There is a size limit that we run into. You get to a certain point where we just go, look, we can't manage from an internal perspective. And you literally just go in, and when you build the WLAN, you go, oh, we're going to use a dynamic PSK, and then you go build that in. But because of the size of that and because of the tables, we run into a limit on how many we can do per platform. So the cool part is a couple of years ago, before I joined the company, Ruckus bought a platform called CloudPath. And CloudPath, it was a SaaS, whatever marketing term, is actually been integrated into the Ruckus platform. And so we can actually do what's known as external Dpsk, in which CloudPath manages the Dpsk, and it uses group Dpsk by default. So if you have a Ruckus network and CloudPath joined together, you then get a portal solution, you get Dpsk solutions, and you can scale it however big you want to scale it. You can go to whatever theoretical scale you can come up with, that handles it. But what happens is, on the backside, it actually uses radius calls between the infrastructure and CloudPath to handle that. And so because it's a radius connection and a radius call, we can also do other things like, so you can get like almost .1x type of control and functionality out of a PSK, and all the end user knows. And so the end user knows, this is my password, just like it's a normal PSK at your house. The end user goes, oh, I just type in, Jim is awesome is my password, and I can type that in on my headless devices, my IoT devices. And so you type that into your device and your Xbox and to other devices that maybe don't support captive portals. And it goes back, talks to CloudPath. CloudPath goes, oh yeah, we know that password is now the unique identifier, and we're going to tie that to Jim. And so then we can also say, well, Jim's on VLAN, 1718 or VLAN 3000, whatever VLAN I'm on, and it can actually put the device into its own VLAN, which becomes really interesting when you start talking about MDU, multiple dwelling, you got high-rise condos. Well, now all of a sudden you can be like, hey, any device that uses the password Jim is awesome is now belongs to this VLAN. And we're going to give him these attributes, and he gets rate limited to this, and he gets all these other functionalities now come into play because we can identify the device not by the MAC address, but by the password that the device uses to join. But as far as you guys know, the end user, it's just a pre-shared key.
Yeah, and you're right. Like the rate limiting is an amazing functionality, as we've discussed 2 years ago. So yeah. Jim is awesome. That's my new favorite password. I'm going to use it in the labs for our course.
You gotta use a special character. So put an exclamation. You put the bang at the end. So Jim is awesome. Bang.
Yeah. Okay. So
change the I for a 1.
The chat, and we will include it in the show notes. So if someone wants to break into our IoT networks at home, they will be able to now. So Jim, you can use, what I'm saying there is that you can use like a personal password that is part of a group assigned to a user to either assign a policy to that user that can be anything, like assign this user to this VLAN or apply rate limiting or block Wi-Fi ninjas.net. You never would do that, right? But you can block that stuff. And also you can use it to present a splash page that is not reliant really on a MAC address, rather on the user group.
Yes.
And that's amazing. And that's, well, I didn't think of that before, really. It's like, it's simple, and it seems to be resolving our issue with the pre-shared key.
And the cool part when it comes to like MDU and this, I mean, anytime when you think about apartments or, condos or student housing at university, anytime you start thinking about that stuff, all of a sudden you just go, wow, it opens up a lot of possibilities. And in the latest version that actually, I think it just came out like a month ago. Yeah, I think it came out last month. There's actually the ability to give the end user, the student, the whoever's renting the condo or owns the condo or whatever, they actually can get their own portal page on CloudPath where they can go manage their own network. And so they log in using their own credentials onto a, shared thing, and they get access to only to their little group. And so they can see who's connected. They can see, how long they've been connected. They can see all this stuff, and they can sort of manage their own little network.
So Jim, sorry to break in. So you're talking about like multi-tenancy on a single SSID with Dpsk managed by a cloud, presenting different splash pages to different tenants, so you don't have the increased airtime utilization of like an SSID on the same channel per 10 different tenants. You don't have all that bollocks. It's all on a single PSK managed by your cloud solution, where all you care about is the PSK being used on these devices. That can be managed by different tenants on their own, using their own login credentials to your solution. Is that the first?
So that's right. And so the tenant then gets to manage just their thing, but as a global administrator, you get to manage all of that. So when a tenant moves in, you basically go, hey, you know what? Here's your login. This is how you're going to go set up your own Wi-Fi. So they basically log in. They can set their own pre-shared key. So that way I don't know it. They set it just like they're setting up their house, and then they put that PSK onto all of their devices, and then they're like, hey, I want to run 2 floors down to my buddy. So I'm going to take my phone. I'm going to take my laptop. I'm going to run downstairs. But you're still on your own credentials. You're just going through a normal office building on the same SSID, but you're still connected. And you could be like, oh, I'm going to print this out. Oh, well, it's going to print out upstairs on my printer because that's who I'm mapped to and that's who I'm talking to. And so now you can then take that connection then kind of goes with you throughout the facility.
That's sleek. And also probably, I'm just like, theory in my head, you probably would be able to integrate it with like some sleeker solutions with like the reception iPad, where you say, okay, I want to have access to the guest network. You put in your sponsor details, and then you're being presented with the QR code that you scan to get your own PSK to onboard your own devices on the network that is just for that particular tenant that you are visiting on that day.
Yes.
Okay, sleek, very sleek. So that's Ruckus. Do you know of any different vendors that can offer similar kind of functionality?
So not from that thing. Most of the vendors that I've seen, they're still either in development, or I do know of third party developers that have, you know, a more advanced portal solution that can also do this. So somebody that is sort of really big into this is RG Nets and their RxG, their revenue extraction gateway. Um, that's an option. Our RG Nets has a very robust portal solution that allows, I mean, for a lot of different things. I mean, it's really robust. There's some other vendors that are doing stuff. I think 11 Software, Cloud 5, or to name a couple. They are doing this same thing, but it's all sort of reliant on a third party device somewhere else. And I think you were talking about like APIs.
Yeah.
And so you can do the API stuff, but it all sort of relies on this. Hey, we got to have this third party thing, and that's kind of where I was talking about earlier with. Unfortunately, what we're having to do, especially as vendors and you guys, is go to your customers and say, hey, yeah, you're probably going to have to put a little bit more money invested into your infrastructure in order to handle this development. And it's a very uncomfortable conversation to have, to say, even if you have Ruckus today, we still have to go back to them and go, yeah, but because of your scale, because you're doing more than a couple hundred devices, yeah, we kind of have to go to this additional service that we have to sell you. And so it's a really uncomfortable conversation that, we're starting to have. And I think in the future, we're going to have more of, we have to go look and license and sell a more robust solution that customers they didn't need to have before now.
Yeah, exactly. And in Europe, we do have our friends from Belgium. They're called WiFlex, and they do very similar thing. And they are not too expensive, actually. Like when I checked their prices, I was very pleasantly surprised. They sell the licenses in packs for the numbers of devices that they support, and it's quite sleek. Actually, it's very sleek.
I think I know WiFlex from somewhere else.
Maybe
and it wasn't you guys talking, but anyway, no, but they are out there, and because this is really kind of a new development, it's been happening, and I think we're going to start seeing more and more and more, and so there is still a lot to learn in this space. There's a lot to especially from a solution side. How do the different vendors handle it? Are they using APIs? Are they using how do they tackle it? And the unfortunate truth is I don't think we have all the answers yet. So you guys are looking for answers, and I'm sitting here going, yeah, well, we can do some things, but we're still not totally there yet, because we're still waiting to see what comes up in this next iOS release.
Yeah, and Jim, absolutely. Finally, I think there was one more topic that we started talking about just before the podcast started. That's quite close to our hearts. How the random MAC addresses are going to affect our beloved Wi-Fi location-based systems, or RTLS.
Yes.
I like your reaction.
Yeah, well, I mean, location is fun enough as it is, right? I mean,
absolutely.
If you've done location more than a day, you sort of have the scars and the bruises to show from how you've learned about location and trying to get to where we are today. And this is, again, this is more of a newer development, I think. And so I'm going to put a disclaimer out here that what I'm about to say is my own personal opinion from a very, very small use case, and I don't have enough data to say anything specific. But what we started noticing is that because devices are using a random MAC address, and so in my testing, I've learned that the MAC address that they will use they use that same random MAC address to probe, which gets into an interesting thing, because many years ago for location, I remember when this came out and I was running Cisco, there was a little thing that says, oh, we want to ignore probes from random MAC addresses because we don't know how often they're changing. We can't count on them. We can't track them. So from that perspective, there's a little checkbox. You'd go in and you'd be like, ignore the probes from a random MAC address. And I need to clarify that it doesn't mean that the device will ignore it and not respond to a probe request. But more importantly, the AP doesn't forward that information that it learns about a device. It doesn't forward that up to the controllers. It doesn't forward that up to the location servers. It doesn't forward any of that stuff. It just says, you're a random MAC address. So yes, you did a broadcast probe request trying to find out who's there. I'll respond. Yes, I have, the guest network on me. And here's my probe response. But none of that information that it learns is forwarded up the chain because we said ignore it. So what's happening is now that the device is connected and it's using a random MAC address, especially when it's trying to say, hey, I'm getting ready to transition to Roam, so I need to find out who else is around me because I'm going to ignore, 11K and 11R that you're trying to tell me about, but I'm just going to do my own thing anyway. So what happens is those devices are probing, the AP responds, but it doesn't send that information to anybody else. So when you're trying to triangulate and say, oh, we think this device is sort of over in this conference room, or even at a larger scale where you're not looking for 1 meter accuracy, and this is my question, have we programmed our networks to not care about those? And so when we start looking at location, are we not listening to those? Are we not caring about those? Have we told our APs not to forward that information up to the controllers, to the location servers, to any other third-party thing, because we've told it many years ago, 6, 7, 8 years ago, ignore them. And so I've actually, my one use case was if you went into your iPhone and said, turn off random Macs, and you were using a burned in Mac, just the network itself would be like, we know that you're connected to AP1 and AP2, AP3, and AP4 can see you because they're reporting that. But as soon as they turned on they went back in and said, hey, enable private, and they connected to the same SSID, the network would say, we know he's connected to AP1 and we don't know anything else about him. So anything that we want to glean, we're trying to glean from just one data point, and that's not enough to say. And so, you can't even say, oh, well, these other APs are hearing that, because that information just isn't being forwarded up. And so when you start talking about troubleshooting with roaming, do my APs even hear that? Well, the AP is not telling us anymore because we told it 8 years ago not to. So there can be legacy coding, legacy settings in there that all of a sudden is doing some unintended things that we didn't think was going to happen. And
8 years ago, when we were putting these things, by the way, I didn't know about that stuff. So it's really good to know that, that access points, they can really ignore the probes from the clients and not forward them to location engines. So that's another pin in the coffin for the Wi-Fi positioning systems.
So we gotta be careful here. It doesn't ignore the probe.
It just doesn't forward it to the location engine. It just responds to the client, but doesn't do anything else with that.
Anything that's in the 802.11 standard, it does all that. That's not impacted. What I saw, and I don't know how big of an impact this has. I don't know. I mean, and it all really depends on the vendor, the code version. There's a lot of other variables in there. But to me, that's like, hey, this is another wake-up call. Go look at your system today and find, did I click something in a code from 8 years ago because that was the thing 8 years ago, to ignore these because we didn't know enough about them. And we just said, we don't really care about random people walking past my facility and I see their probes. I only care about the people that are connected. So I can ignore these. And, when it comes to coding, I don't know much, but I do know that, leftover code from a long time ago that wasn't commented well usually ends up staying there because nobody knows what it does. And so they're afraid to remove it in case they break something. So your code gets really, really big. You got 18,000 lines, and somewhere in this code is, these 3 lines that say ignore 26 A and E. And so these 2 lines of code can be like, it can really screw things up today because we didn't count on it. So it's really inherent on us, and I'm saying vendors, network operators, Wi-Fi professionals, to kind of start looking at it and go, hey, what legacy things did we do 8 years ago that are going to start breaking today? And location is just one that came up. And so again, I don't have, this is just me personal and not from my company and not from any other company, not from any other vendor. It just screams to me, we have to go look at this stuff because the problem's only going to get worse. It's not going to get better, at least not soon.
Thankfully, we are relying a little bit less today on the Wi-Fi positioning than we used to several years ago, and also our devices were not actively used. They pretty much don't probe these days, so it's difficult to locate them anyway. And this just adds another problem to existing list of problems with Wi-Fi positioning. Do you guys think that open roaming can fix a little bit guest access with uh, with MAC randomization issues that we have with splash pages? Would that be something that people they would be willing to use instead of splash pages?
Yeah, I think it's just about adoption, right? It's how many users are going to download that certificate or install that profile. It's just adoption. So it's a great solution, but compared to just connecting to an open network without having to install any profiles or certs and stuff, it's
That's the thing. You don't have to do it anymore in the near future. So the profiles and installing the certs, this is a thing of it's still there, but it's
you might
kind
have
of
to enable it though, right? You can still disable it or something.
So you said something. You said in the near future.
Hopefully.
So here's a little reveal. I'm gonna throw out a nugget for everybody. I actually have open roaming running in my network today.
Well,
I have
had it in 2019 in my house.
well, but I'm using it's a test system for something that's happening in the Bay Area.
Okay.
And I have like 14 devices that I use here in my office for testing different things. Trying to use open roaming. 56% of my devices failed. It wouldn't support it. I couldn't use it. I can't use it today. So I think it's a solution. I don't know how good of a solution it is today because of client side support and also the setup. You have to, it's not an easy thing to so I think it's possible in the future, near future, maybe longer future. I think it is a decent option, but I still don't know enough about the identity providers of open roaming.
Yeah. So it's been a while since we actually were testing it, and I can see from what you've just said that we are still seeing similar hurdles on the road with
It's an interesting option. I don't think it's ready. It's not something. I mean, MAC randomization is here today, and open roaming could be a solution in the future. But
yeah, that sounds about right. But thankfully, like what we do see is like the bigger vendors, they start to support open roaming straight out of the box. Like I think Samsung is supporting, like all the new Samsung devices, they do support open roaming. I'm not sure about Apple. Haven't tested it. Have you tested open roaming with Apple recently? Is this out of the box thing, or you still have to onboard it, install like a profile to use open roaming?
I still had to so my testing was from a month ago, and I had to install a profile.
Okay.
And that was on Mac OS, iOS 14, and then I actually have an old iPod, an iPod Touch, but that's still 12.5, iOS 12.5. Didn't work.
Yeah, so it doesn't support the Hotpoint 2.0 and stuff.
So there you go. So now we're back. So it's not necessarily, and that's the problem, right? Is I can hold up all of my different devices that I have. So that's an Android 10.
There we go. Jimmy's showing off all his toys.
Yeah. So I got an Android 8. Let's see. I got my iPhone running iOS 14. I got.
Who pays for all these devices?
I got an Amazon Kindle that's 2 years old that only supports 2.4, and guess what? It doesn't support Hotspot 2.0. Mm-hmm. There's my iPod Touch that's running 12.5. Yeah, not supported. That's Android 8, so it doesn't support it. I got some Android 4. Oh, there's my
Android 4. It's like 2011, man.
It's my granddaughter's tablet, and my granddaughter's 6, and I bought it for her 3 years ago.
Okay.
Android 4.4. So
yeah.
What was it called? The KitKat?
Dude, I don't remember what I had for dinner last night. You want me to remember the name of Android 4.4? You're right.
Our Wi-Fi networks would work so well without all these Wi-Fi clients, wouldn't they?
Thank you. Thank you. So I got, the other thing we haven't talked about, Chromebooks, Chrome OS.
It's not as popular in the UK, I don't think, but let's talk about them.
I'm American, so we do everything American, and we love our Chromebooks, especially in education. They're not randomizing their MAC address, and they don't support Hotspot 2.0. So
they're making your life difficult and easy at the same time.
Yeah. So yeah, that's on the row of laptops behind me. I can't fit all my laptops on my desk, so
you need a bigger desk.
I got a big desk. I just have 18,000 charging cables and 1, 2, 3, 4, 5, 6, 7, and 9 devices.
Crazy.
And if you're watching this, then you can see all my shelves behind me. So if you're not, I have a bunch of shelves behind me with radios and fun stuff.
Access points, antennas, caps, WDAM
I can see 13 white enterprise-grade access points there on the top 2 shelves alone.
Yeah, if you looked at the brown box, that's a new in box one, so it's actually 14.
14.
Anyway.
Okay, have we covered everything that you wanted to cover for Mac randomization, Jim, or is there anything else?
Have we covered like what else does Mac randomization impact outside of wireless LANs, or is this something that we still want to include?
So there's a couple things I want to talk about, and this is above. We were talking about when you get an IP address, or when you get when people go, oh, the Wi-Fi is broken. Well, you got an IP address, so the Wi-Fi is not broken. Well, what about when you don't get an IP address? So I ran into a problem many years ago when I was at the airport, where my DHCP pool ran out of IP addresses. And it's because I'd set the lease times way too long. So I was running a /18, which is 16,000 IP addresses, but I'd set the lease time for like 8 hours because I was like, I don't want to have DHCP requests going in and out. But what I didn't realize was when you set a DHCP lease timer of say 8 hours, your DHCP server will then reserve that IP address for that MAC address for 8 hours. Well, then it also holds it for one additional lease period. So when I said, hey, I'm in a high churn environment where I might not have more than 11, 12,000 clients at any given time, but I have 80,000 MAC addresses in a day. What was happening was I was reserving that IP address for literally the entire day for a device that was only going to be there for 30 minutes. Well, then I just ran out of IP addresses. And so then I went the opposite way and said, I'm going to set my lease timer for 30 minutes. That way I can churn it really fast, except that broke Apple at the time because they didn't like it. They didn't like really, really short lease times. And so I was on Twitter, I think, or on Slack. And
what were they doing? Blacklisting your SSID?
Say again?
Were they blacklisting your wireless LAN, your BSSID?
No. So the story goes, I was having problems. I was complaining. Christian Roberts, is that his name?
Yep. Karen.
From the UK?
I don't know. Whatever. He's on the pubcast. But anyway, he was like, dude, you need to look at DHCP option 51. And so for whatever reason, I'm like the world-renowned expert on DHCP option 51. If you don't believe me, go to Google and type in DHCP option 51 and tell me what's the number one result.
Okay, let me check.
Yeah, go ahead and check real quick. We'll wait.
Option 51. It's gonna be your blog, man.
Yeah. So I'm like,
there we go.
I'm the world-renowned expert. I'm like the number one hit on Google for DHCP option 51. So what I learned is, and so what I'm learning now is that Apple devices still request 90 days. Why you don't want an IP address for 90 days is beyond me, but they do. But Apple now recommends on a guest network a 2-hour lease, and on a corporate network an 8-hour lease. But my fear is Windows devices or Windows DHCP servers have a default lease time set on the server side of 7 days. So if you didn't go in and adjust that, and devices start using random MAC addresses, every day that a device comes in, he's going to present a new MAC address to the network. And so the DHCP server is going to say, oh, new MAC address, new IP address. And so after 13 days, if you go in every day to a coffee shop or something and you're running this long lease time because you're going to prevent the 2-packet exchange for a DHCP renewal because it's going to crash your network, or 2 frames, you're going to run out of IP addresses because it's going to hold the IP address for 14 days, even though you're never, so one device can actually occupy 14 IP addresses out of your DHCP pool. So look at your IP lease times. And personally, I'm more in the 4 to 6 hour range. That way we know that when they start changing after 24 hours, any lease that's been held is going to be flushed. Any shorter, Android now is the biggest problem because they just hate these, and they'll just ignore the lease time. They'll be like, oh, you want to give me a 30-minute? Fine, I'm just going to ignore it. And I'm going to go with my 90-day lease, or I'm going to go with a 7-day lease, and I'm not going to send my DHCP renewal packet. But then networks go, well, you don't have a valid IP address anymore. So any traffic that's destination your IP address, I'm going to be like, well, he's not valid anymore. So I'm going to drop it at the AP and I'm not going to forward it to the device. So the device thinks he's connected, but there's no traffic coming to him anymore or leaving anymore because the network said, screw you, you don't have a valid IP address. So we're just not going to send you traffic.
Well, that's a proper punishment for not respecting the rules set on the DHCP server side.
Well, but it's a client side issue. But then again, then you have your end user who's standing there holding his phone going, your Wi-Fi is broken. And the funny thing is if you do have an old device that doesn't change its IP address, it's not going to break either because, well, he's going to get the same IP address for years to come because he's in there every other day and he's held so he just keeps renewing that same IP address. But newer devices are going to break because they're not going to have their own little special reservation. So look at your DHCP timers on your DHCP servers, get them down below 12 hours at least. That way, you know that it'll flush by the time it changes every 24 hours. The other thing, how many times have you done a reserved DHCP?
Really? Like, honestly, last time I had to do it, it was like, I don't know, 5 years ago for some kind of a client that really wanted to have reserved IP addresses for some specific reason. I don't do that too much these days. How about you, Matt? Do you do quite a lot of DHCP reservations?
Never, really.
I just try to have like a pure DHCP networks without any stuff like this.
Oh, I use them all the time. Mainly because I don't want to go into the device and set the static IP, but I always want to make sure that device always gets the same IP.
If you need it.
It's because I'm lazy. That's my shirt. You haven't seen my shirt yet.
No. Lazy is a very strong word. I prefer to call it selective participation.
Yeah.
Nice.
So I don't like staticking stuff because I just don't want to go into all my devices. So I just go to my DHCP server and say, hey, guess what? This guy is always going to get this IP address because I know it's never going to change. And then I can start building firewall rules. I can start building other types of ACLs. I can build all these other things off of the stability, but if all that changes, now all that changes. Yeah. And the last thing I'll hit you guys with is home networks. So a lot of people run home networks where they have teenagers or, almost going to be teenagers and they don't want to ever do what they're supposed to do. So you limit their ability to access either the SSID itself or what they can get to or when they can get to it. But what is the key identifier that says little Johnny's, iPad or little Johnny's laptop isn't allowed to go play games or stream YouTube or whatever it is, except for these specific hours? What little key piece of information is used to tell little Johnny, hey, you're not allowed to do this anymore because you haven't done your homework yet, or it's school time, or it's chore time, or whatever? What key piece of information have we been using to limit little Johnny?
hopefully user ID, but IP address is not unusual.
Also, MAC address, many home networks. So I'm not talking about, you have a Cisco network, or I'm just talking about whatever the ISP shipped you when you call them and say, give me service. What do they use?
Probably MAC address, since
They
we
use
want to
MAC address.
use that as an example here.
Yes. And so if now that all of a sudden, if changing it every 24 hours becomes a thing, now you just sit back, now he just tells everybody, hey, you know what? Make sure that your parents limit you this one day, and then 25 hours later, the limit's gone. You just don't tell them, and you can go do whatever you want. The other thing is if you want to do a directed denial of service attack against a network, before we just go in and go, hey, this MAC address, we don't like them, block them. Well, now they just go forget the network, or go do this, go do that, and then rejoin. Oh, I have a new MAC address. Now I'm back to creating mischief. The bar to create mischief has been lowered in a couple of different ways where we've counted on that MAC address not changing. And I'm going to bet you that somebody listening is going, well, crap, now there's this fifth thing that I didn't think about that is now going to happen that's going to cause me problems. So it's
And what have we done for these poor kids now? It's like parents, they will now be looking at the MAC address blocking rules on their home Wi-Fi routers. The kids are going to hate Wi-Fi ninjas and you, man.
It's not me. But think about kids, and especially teenagers, when they learn something. I mean, every kid in the school is going to know it in like 30 seconds. I mean, it's going to spread like wildfire, and it's nothing we did.
So what do we have to tell them? It's like with MAC randomization being used now, and with the depletion of IP addresses on the DHCP server, if the parents, they set up too long lease times, they can put denial of service attack against the DHCP server to show the parents who rules the world in the household.
There's lots of things. The bar to create mischief has been lowered, and it's always been there, but it's been something you had to know to do. You had to go, I can change my MAC address, but you had to know to do it, and you had to take the time, and you had to know where to click, and you had all the other things. Well, now you just wait. And so there's lots of things. And so this is my biggest message, if I can tell anybody. Two things, really. Okay. 26A&E, and look at your networks. Go look at them. Look at all your configurations. Look at what you've set up. Look at your rules. Look at all these things and go, do any of these things rely on the MAC address as that one key field in order to do whatever it is I'm doing? Because I don't know what it is. I talk to people all the time, and they're like, oh, yeah, well, now I can do this. And I'm like, wow, that's a really good idea. I never thought of doing that. And so, but you have to go back and look at it, and look at your use case, look at your networks, and say, what is going to happen if this one piece of information changes and then starts changing every 24 hours? Because we have time to prepare now. But I don't think when iOS 15 drops, we're going to have, I don't think Apple's going to give us that grace period anymore. I think they're going to be like, look, we warned you last year and you didn't listen, so that's on you.
Fair enough. Matt, what are you using to block internet for your wife with a Siri command?
You've seen that, right? So using a Mist API and policies and labels to block it. She didn't like it too much, especially when she was on a work call, and I thought it'd be a bit of fun. But
how do you identify her device? By what? By MAC address or by user ID?
Yeah, so MAC addresses.
Oh. That's
So
today and see if it's still working.
Mm-hmm.
So Mrs. Starling, this is how you're going to get around Matt and his API stuff.
Yeah, turn on private MAC address.
Yeah.
Well, just turn it on. Just turn it on or turn it off. Let him set his rules. Let him build his APIs, and then just go turn it on, and problem solved.
Yeah, I've only just got back out of the doghouse, so I'm not going to be planning on doing it again anytime soon. So.
Well, you just revealed the secret, though. You based it on her MAC address.
Yeah.
So that's going to become a problem.
Mm-hmm. I think I would have a bigger problem if I tried doing it again anyway, to be honest.
Okay. So guys, I think we've discussed everything that we wanted to discuss today. Do we have anything else that we wanted to add on before we close?
I don't know. You have the list.
Jim, thank you very much for taking the time out of your day. I know it's very early for you to talk to us. And great podcast. Again, I'm sure I'll be sending this to plenty of our clients and students in class to cover the MAC randomization. And I wonder what will be happening the next time we talk to you, if it will be another global pandemic, if you've changed jobs again, or what's going to be happening?
I don't know. I guess we'll find out, huh?
Yeah. Well, yeah, thank you very much. Thank you, Jim. Thank you, Mac. I will speak to you both very soon.
Thank you very much, guys.
Thanks.